G'day everyone, how you going? Another episode of Tech Talk. It is Friday. We're actually veering back around to a topic that we've recently had, and that is the single-phase lighter machinery discussion. I've had a few phone calls and a few messages, and seems to be a little bit of a hot topic. I guess probably the conversations being had is a bit around tooling, but also very, very much about power and that sort of thing there. What about yourself, Josh? Do you want to kick off? What sort of feedback have you been getting?
I can't say I can relate, Mike. I don't have problems with the small machines, power or tooling because, I don't like them.
And that's another episode of Tech Talk. Thanks very much for joining.
No. I think some of the messages that we got from people was basically saying that this is the market that they're pursuing, or these are the factors that they're dealing with, and they just have to have something that is small, lightweight, single phase. How am I going to get the most productivity out of it based on some of the points that we raised in the last one? So it was really good. Thanks for all the feedback. And so we've brought Tim and Hayden back because they got us into trouble in the first place over this. There's a few factors, recommendations from Tim and Hayden that's going to ensure that you get the most out of a single phase grinder. And therefore get the most return on your day's work. I'm going to start this time with Tim because he was second last time. Tim, how do we get the most productivity out of our single-phase grinding machines from a tooling perspective?
From a tooling perspective, well, we know that grinding is pretty much, in essence, about power to weight ratio and what sort of power we can get on any given amount of point pressure. We know we're very much at the light end of the spectrum with these machines when it comes to power, but also weight. So we have to make some adjustments from what we're actually putting under the machine, or what we may be even adding into the equation to help the tooling do what we need them to do. So, the sort of things that we're thinking about automatically are smaller segments, because we're trying to keep the same or a similar amount of kilograms per square centimetre or square millimetre or whatever you want to call it of diamond that's actually in interfacing with the floor.
So that's what you mean by, just so we can clarify, that's what we mean by point pressure, isn't it? The amount of weight of the machine on a particular point being the tooling.
Absolutely. And so we want to try and maximise that within the limitations of what the machine can actually turn over. So we're talking about things that make lighter weight machines more effective. So smaller segments, maybe things like investing in PCDs if we're looking at more prep applications. A lighter weight machine is probably going to take some advantage or open up some opportunities to PCDs that some of the bigger machines don't do, because it's not putting so much pressure on the PCD. So the PCD might spend more time just skating across the surface rather than starting to burrow down and exposing aggregate and damaging themselves. So a PCD, if the customer's doing prep sort of work, we'll probably get a lot more lifetime out of a set of PCDs and certainly better productivity out of the machine. So that would certainly be something to have in the toolbox, particularly for coating removals and glues and things like that. They'll probably find that far more effective in many applications. And we're also talking about things like grinding accelerators, things like cut-sick that are actually going to help introduce wear on the diamond, where the actual weight of the machine or the that friction that the diamond is just not being able to create with the floor to create the wear in the tool, so the tool will do its work properly and efficiently. Adding in that cut-sick will definitely help encourage that and fill the gap where the machine just doesn't have the weight and the power to maybe in some situations get that tool performing the way that is optimal or ideal. You
mentioned weight and power. Is that a bit of a segue into Hayden there to discuss the power, is it?
Oh, wow. Single phase and power, hand in hand. Gotta have good power. Too many guys are trying to plug into house power. They're trying to plug a 15 amp machine into 10 amp and they're expecting the machine to perform normally. It's just not going to happen. A lot of the small guys, look at small generators. Portable, can get them around. Site power is then a non-issue if it's an open slab or it's an existing house, a bathroom down the back somewhere, a bungalow. All of these things become not a problem because you bring in your own power that is good. You can rely on your power, because what's going to stop you at the end of the day? Run out of tooling, have bad power. They're the things that stop you from making money. So look at generators. But when you look at generators in that smaller sort of compact size, don't undersize your generator. Look for future, something that you can maybe run a small 3-phase on later on when you do get bigger or expand or whatever it might be. So, something in your 16 kVA area will still run a small 3-phase grinder, the likes of, your 530s, your X6s, T5s, stuff like that. They'll all run on a 16. So, don't just go the cheap generator, 4 or 5 kVA just to get your little machine through. If you're going to invest, have a look at the next size up and see, because you probably find the footprint and what you're carrying around isn't that much bigger by going that, but you can expand later on. Yeah, that's right. So that's really important to don't just look at now with the power, what you're looking at. But certainly at 240 volt, as I'm sure we've discussed at some point, is your limitation is you can't change your voltage. You've got really restrict on how many amps you can have in there. Even down to things like breakers. The breakers in residential that people use are different to what commercial use. So you're likely to find that your machine's going to have issues when you plug into house power compared to bringing your own generator that works every time when you turn the key. Really important factor in there, guys.
Can I just touch on the voltage and current for a minute as well? Probably one of the overlooked piece of equipment that might make a big difference in this scenario is actually the single-phase power lead. More so than any other form of power, when we compare it to 3-phase, voltage drop is a massive thing. And you don't see that. You don't see voltage drop. You think because you've got a single-phase lead running from your machine to the power point, you've got the power. But if you're running, like a 1.5 mil or a 2 mil cable compared to a 2.5 or something, and you're on a 30 metre lead, which most sort of builders' leads are, you'll get a fair bit of voltage drop. And as soon as we get voltage drop, we're then bringing that power availability to the motor down even further. These machines aren't very sophisticated. They're just going to tell you that they're overcurrent or that they're overheating, and that's about all the information they give. But you've got to make sure you've got like a 2.5 mil flex cable that that you're going to get you're going to minimise that voltage drop and therefore carry the most power to that motor that you've got available, which is already limited, as we've been talking about.
It's always funny, isn't it, when we talk about not having enough power and then we talk in the same breath about the machine overheating. It doesn't sound right, does it? But of course the machine is working harder to provide without enough power. So therefore it is working harder, so you will get overheating and that sort of thing there.
Yeah, well, when the voltage is low, the machine's trying to do the job you're asking it to do, so it'll compensate by pulling more current. Current's what creates the temperature of the machine, and current's what's actually being regulated by the circuit breaker on the supply side. So there's nothing that's switching out because your voltage is no good, unless you've got a frequency inverter inside the machine that picks up on that. But the thing that's always, the thorn in people's side is the circuit breaker cutting out because of a current overload. So yes, that's the dynamic we've got going on there.
I have one final question before we finish for the day. If I've got a generator on the ground floor and I'm working on the second or third floor, am I going to experience voltage drop because I'm pushing it up to the second level?
I know you like to take things to the next level, Josh, but that's ridiculous.
What
I would say, Josh,
here?
once you've got that power up to the second level, just drop it back down to the ground.
So we're talking about supplying your own power and good power and overcompensate to future-proof yourself. We're talking about smaller, say, single segments with grinding accelerators. So all these sort of good practices just to back up that single-phase machinery that you've got.
Yeah. Absolutely. Turn up to do a full day's work from the time that you turn up. Don't mess around, because those machines have to be running all the time.
Cool. Speaking of a full day's work, I think that's about it. Got to be here at 1.
Thanks,
I like
gentlemen.
the sound of that, Mike.
Cheers, guys. Nice to see you guys. Absolutely.
Have a great weekend.